All right, so we're going to look at some applications of sequences that are related to multiplying as we go to the right. Now, we've had some lessons on what are called exponential models, and I had been skipping this. So today's a good day to go back to this. So if we want to figure out this model, we're not using sequences here like we are here. What you want to do is figure out, well, what you're multiplying as you go to the right, and then figure out, well, what would you have started to multiply, and then go to the right. That would be the A and the B. Okay, so looking at the Y values, what are we going to be multiplying as we go to the right? Okay, if you want to send a chat. So as we're looking at the Y values, what do you think we're going to be multiplying as we go to the right? Okay. Correct. Vi, correct. Okay. Okay, Tony. Anybody else want to share what they think? Now be careful, because as you go to the right, the bottom of the fraction is changing. The top of the fraction is not changing. So this 7, we could write this as 7/1. So you might say, oh, we're multiplying by 3, but that's true. But where are we multiplying the 3? We're not multiplying to the top. We're multiplying to the bottom, which means we have to be multiplying by 1/3. Since 1 on top means 1 times 7 is always going to be 7. So it's a real easy mistake to make. Okay, and I'm no different. I can do that too. Right? Okay, so if we're multiplying 1/3 as we go to the right, in this model, we now know that the thing that has the exponent would be 1/3. But this isn't a sequence, this is an exponential model. So we start when the exponent is 0. Okay, well, what would have been the first number we would have multiplied by 1/3 to get 7? Okay, well, if we're going to multiply 1/3 as we go to the right, then we'll divide as we go to the left, which means we're going to times the reciprocal. Okay, so I'm going to call randomly on somebody. Okay, Mr. Christian, what is 3 times 7? Okay, Mr. Wellman, what's 3 times 7? Now, I know those two individuals know what 3 times 7 is. Anybody want to volunteer? Thank you, Tony. Yep. Go ahead.
21.
So that means when the exponent is 0, this would become 21 times 1. Okay. Now, again, don't get tripped up between the difference between the exponential model, in which the exponent can be any real number, not just whole numbers. It looks very similar, but it's just a slight difference because the domain values can consist of all possible decimal numbers. Whereas when we're looking at sequences, this is n minus 1 because n is never 0. N always starts at 1. And when n starts at 1, we get 1 minus 1. We get a 0 exponent. And that's how these are related. They're very close, similar to each other.